Masters and an MSc degrees of the University of Ife, respectively in 1981 and 1985 in engineering physics, material science option. He proceeded to the Swansea University College of the University of Wales in 1986 and bagged a PhD in materials engineering in 1990. In 1993, he received the Master of Business Administration degree of the University of Wales at Swansea Metropolitan University, UK. Professor Babatope was a postdoctoral scholar at the Casale Institute of Applied Chemistry of the Hebrew University of Jerusalem. That was between 1989 and 1990. And Chemical Engineering Department of the Swansea University between 1991 and 1993. He was a fellow of the U.S. African Materials Institute of Princeton University, New Jersey, USA, and that was in 2004, and of Pan-African Materials Institute in 2018. He was a beneficiary of TETFund National Research Fund Award in 2015. He has mentored numerous young Nigerians, and some of them are professors even here at OAU. He has published in different local and international journals, helped organize numerous local conferences, and attended numerous local and international conferences. Professor Babatope was a member of the National Committee on Engineering Materials, set up by the Honorable Minister of Science and Technology between 2001 and 2002. He was appointed Director and Chief Executive Officer of Engineering Materials Development Institute, National Agency for Science and Engineering Infrastructure, NASENI. That was Nakure, 2005. He was chairman committee on the production of a blueprint for the development and utilization of new materials in Nigeria. That's the Advanced Materials Group Raw Materials Research and Development Institute, Abuja, 2010. He was appointed a member of the Tenka Board of Directors of National Engineering Design Development Institute at Inewi, Anambra State. Professor Babatope helped found the Material Society of Nigeria, now Material Science and Technology Society of Nigeria in 1999. He's a fellow of the Institute of Materials, Mining and Minerals of the UK, fellow of Material Society, member of the Polymeric Institute of Nigeria, among others. Professor Babatope is a community activist in Egboroland and the Church of Nigeria Anglican Communion Affairs, especially things having to do with youth and other development matters. He's happily married with children, and I hereby introduce to you the inaugural lecturer of today, Professor Babaniyi Babatope. You're welcome.
Mr. Vice Chancellor, sir, the principal officers, dean of faculties, provosts, head of departments and units, highly distinguished professors, and esteemed traditional rulers, Kabiyesi in absentia, His Olori on seat, and the high chiefs, many of whom are present, spiritual fathers, distinguished guests, students, ladies and gentlemen. I'm standing before you on this God's divinely appointed day and time to deliver the 384th inaugural lecture of Obafemi Awolowo University, Ile-Ife, made possible by divine arrangement. I am hereby personally welcoming each and everyone for finding time to be present physically and those watching live from different parts of the world. This lecture titled Materials is Everything and Everything is Materials, my adventure in the world of infrastructure and energy materials, is being presented as a mixed grade. However, I want you to feel at home with me as you will not be bored with jargon. Please, permit me to ask everyone seated in this hall if there is anything around us here that is not materials. Look around, sir and ma, from our hair strands, the clothes we wear, our shoes, our bones, flesh, blood, and other body parts and organs, the chairs and table, the floor we are walking on, the roof and ceiling of this building, the cars and lorries we drive and other automobiles, the public address system, the aeroplane, the water we drink, and even the food we eat, the sand, rocks, and stones, name it. They are all materials. The task before me is to take you through my journey in this arguably the most highly interdisciplinary field of study, material science, ever known. It cuts across all known science, engineering, and technology related disciplines. The first inaugural lecture at the Department of Physics, University of Ife, now Obafemi Awolowo University, was delivered in April 1982 by our erudite and legendary retired professor of physics, Professor J.B. Aladekomo, an atomic physicist. The inaugural lecture, titled Replenish the Earth and Subdue It, was hugely material science by the time we looked deeply into all the application areas covered. The lecture was followed by those of Professors Oluwole, Balogun, Ogunade, Amusa, Olomo in 2005, Ojo in 2013, who incidentally was the first inaugural lecture for a product of engineering physics at Ife, and Professor M.A. Eleruja in 2018. Today's inaugural lecture, the first in material science under the engineering physics program of this university, is therefore the 9th in the series from the department. It is noted that the highest single-digit number in the decimal system is 9. It is also considered a lucky number in many cultures where it is associated with longevity and good fortune. It is also associated with spiritual growth, selflessness, and humanitarianism. The number 9 symbolizes divine completeness or conveys the meaning of finality. Sir, today, the 9th of July, is very significant. With the 9th inaugural lecture being delivered from our department, this also is the 7th month of the year 2024. July is also symbolic as it has been affiliated with insightfulness, intuitiveness, truthfulness, introspectiveness, intellectualism, and wisdom. It is associated with completeness, perfection, and it is of great spiritual significance. This is July, my birthday month, that of my wife, and one of my sons. Happy birthday to them. Already celebrated a couple of days ago. Please come along with me for my real journey through infrastructure and energy materials road. The major area of my academic contribution to knowledge, it is about growing, changing, and coming to terms with who and what I am, and loving who and what I am. It has truly been an adventure. I was admitted to the University of Ife in the Faculty of Science in the 1977-78 academic session, having also written the entrance examination into the universities of Ibadan and Lagos to study medicine and engineering, respectively. This immediately followed an exciting and successful challenging management to leadership opportunity bestowed upon me in the 1976 and 77 academic section. as the senior prefect or the head boy of Methodist High School, Ilesha. My journey, which began in Ijebu-Jesha, after helping my late father between 1969 and 1973 as a newspaper boy, first took me to Origbo Anglican Grammar School, Moro, then to Ilesha in 1975, seeking knowledge, and then forward to the University of Ife in 1977. Here I am at Ife Land since 1977. I have then remained on course. I recognize and accept very early that my adventurous academic journey must just be traveled, no matter how bad the roads and accommodations may be. I have then remained on course in structural property relationship research materials throughout my career, cutting across several areas and making me to work with researchers from diverse fields. Meanwhile, many of the properties of behavior of materials are consequences of the changes in the structural property relationship. Mr. Vice Chancellor, sir, please permit me to briefly say few words on the engineering physics program at Ife for the records. At the takeoff of this program at the University of Ife, students had to be drafted in from the Faculty of Technology admission list, especially those who were unable to secure admission due to oversubscription of the various engineering programs. Such students were given the opportunity to study engineering physics. They all excelled in 1980 with a bumper harvest of first-class candidates. They are today leaders of top research and academic institutions, mostly in North America. Many initially did not know what the course was all about. Even till today, the question was, and still is it physics or engineering in the Faculty of Science? From my own understanding of the impact of the program due to my wide exposure in the real world of science and engineering, engineering physics is a missing link between what is traditionally known as physics and the classic engineering. It is a science link of the engineering discipline, since the foundation of any engineering course is the physical science, especially physics. Engineering physics or engineering science, therefore, refers to the study of the combined discipline of physics, mathematics, and engineering, particularly computer, nuclear, electrical, electronics, materials, or mechanical engineering. What then is materials? The interdisciplinary field of materials science, also commonly known as material science and engineering, is the design and discovery of new materials, particularly solids. It incorporates elements of physics, chemistry, and engineering, hybridizing metallurgy, ceramics, solid-state physics, and chemistry. My adventurous academic career, research career, began with my innocently venturing into the world of infrastructure development for academic research because facilities for carrying out basic tests on materials were non-existent. Being carefully mentored and guided by my allocated project supervisor, the then Dr. Olawumi Ajaja, I chose to go the way of mechanical methodology. The first challenge was to design and construct a constant stress creep testing machine in 1981. The machine is still standing till today with the one the university purchased in 1986. That is the third one. The first one was the one I built, which was refurbished in 1996. And the B part is a zoomed part of the main section of the machine. At a high temperature, metals, polymers, and ceramics exhibit time-dependent plasticity. If a constant stress is applied and maintained constant, despite any change in cross-sectional area, the material will deform over a period of time, irrespective of whether the stress is greater or less than the conventional stress at that temperature. A single test can be run for several hours and even days or weeks. At that time, my tests were run for 16 to 24 hours uninterrupted by power cuts. Creep is then the limiting factor in the selection of materials for use at high temperature. The long-term durability and lifetime prediction of materials used in turbines and turbine blades, parts of automobile, aerospace and jet engines, oil and gas installations can be determined. Most high temperature designs are governed by creep properties of the structural material. The first major and serious research engagement was my master's degree project. I was privileged to be one of the first sets of the engineering physics postgraduate students in 1983. Meanwhile, I was appointed a graduate assistant in 1982. The study was about the intimate connection between the process of glide and recovery during creep in a class 1 alloy. The shape of the creep curve is often believed to be directly related to the operating creep mechanism. The shapes are normal, inverse, linear, and sigmoidal transient creep curve. The figure 1 as shown shows the various possible creep curves. Pre-straining at its stress level, where it indicated an inverse transient creep curve shape, showed a change to linear creep at 7% pre-strain level and normal transient creep at 14%, as shown in figure 2. The most joyful and encouraging part of this project was that the equipment used for this project, which became my first academic contribution, was the constant stress creep testing machine I built as an undergraduate student. It was found that inverse, approximately linear, and normal creep curves were indicated at 0%, which is on pre-strained, 7%, and 14% pre-strained annealed samples, respectively. The normal creep curve, the normal transient creep observed when pre-strained to 14% would appear to be a direct consequences of the initial dislocation density between being higher than the steady state value. Mr. Vice Chancellor, sir, creep research of structural alloys was pioneered at IFE with in the early 80s, with the investigation I carried out in 1983 to 1984. To the best of my knowledge, there was no other creep research ever carried out at the Department of Physics after this, and no other institution in Nigeria was and is known to be involved with creep research. Polymeric materials research. I began polymer research on stretching or drawing of crystalline polymers and composites. Meanwhile, stretching has been known to produce a realignment of the molecular chains and crystallites with certain crystallographic planes along the draw direction, which often resulted in increased mechanical properties such as the modulus and the strength. The wide-angle X-ray diffraction, WAXD pattern, and scanning electron microscopy were correlated with the changes in the moduli and strengths at the various test conditions. It is well known that samples molded by extrusion or injection molding process often exhibit marked anisotropy in their mechanical properties, which is of particular interest of significance in short fiber reinforced thermoplastics. This anisotropy is on both macroscopic and microscopic scales. I found that the degree of orientation in the unreinforced nylon 66 was much less than that of matrix orientation in the composite at similar draw ratios. Mr. Vice Chancellor, sir, the late 1980s and 1990s, when I started my PhD research work, was an era of searching for high-performance structural composite materials that are lightweight and of high specific strength for the replacement of existing metals-based ones, especially for use in the defense and aerospace industry. The Iraq-Kuwait conflict of that period gave the US, in particular, the greatest opportunity of testing the greatly improved revolutionary strike fighter jet bomber series, which the traditional radar systems found hard to detect when on mission. The body of this jet was, the jet is as shown, that's an example where they are parked before going on the mission. The particular series that fascinated me most was the F-117 bombers that did havoc in blasting bunkers in Baghdad undetected. When it was first used, it caught Iraqi defenses off guard. The body of this jet was made largely of carbon black, carbon-carbon composites, and other radiation-absorbent materials, combined with sophisticated computerization and electromagnetic emission systems as part of the complex proprietary secrets behind the design. I had just completed my PhD in materials engineering, believing then with great hope and enthusiasm that this technology would be of interest to the military research establishment in Nigeria. However, the realities upon my return to Nigeria were different. After completing my PhD research work in the late 1989, the challenge before me was to continue my adventure to learn from the world best in modern technology development while awaiting formal award of my degree. The country that fascinated me most at that time was the State of Israel. Though controversial, I was inquisitive as a scientist, researcher, and academics to know more about what made Israel tick technologically. In the course of my PhD program, I had opened a communication channel with the Israeli embassy in London because of my curiosity to know how a small nation could excel so much in high tech. I wanted the embassy to recommend the best laboratories or universities that was then active in polymeric materials composite research. Hebrew University of Jerusalem and Technion Israel Institute of Technology in Haifa, that's northern Israel, was suggested. The Kasali Institute of Applied Chemistry in Jerusalem agreed to host me for 6 months to know more about Israel and with a research group to gain more experience. This afforded me the opportunity of visiting most important biblical sites in Israel, which also contributed to my spiritual growth by rededicating my life to Christ on one fateful evening at the city of David in Old Jerusalem. A polymer composite research team led by Professor Gad Marom gave me the opportunity of this mini postdoctoral research period from 1989 to 1990. I was able to interact and work with polymer chemists and polymer composite experts at the Institute in the development of new composite materials with application in defense and the medical field. The treatment of many human disease conditions requires surgical intervention in order to assist, augment, sustain, or replicate or replace a diseased organ. Such procedure involve the use of materials foreign to the body. These materials, known as biomaterials, include synthetic polymers and, of a lesser extent, biological polymers, metals, and ceramics. With these materials, I chose to work on a prosthetic trachea that mimics the natural body organ. The trachea is an organ in our neck. It was designed and fabricated using composite laminate method, which was already being used in the fabrication of arterial prostheses within the composite group. I learned from the group's experience on the arterial vascular grafts in the fabrication of the trachea prostheses. All these and others were development projects carried out in collaboration with surgeons at the Hadassah Hospital, Enkerem, in Jerusalem. Our results show that in vivo and in vitro experiments of the trachea prosthesis prototypes were fairly satisfactory in meeting up with the stringent mechanical property requirements of a trachea. This was in view of the very short time available for the investigation. Plate 3 shows the first is a sample. They are the trachea that we use in a sacrificial dog, in sacrificial dogs. The middle one are the ones, the middle and in plate B, they are the ones that are used for testing both the longitudinal and transverse mechanical properties. Our results showed that, okay. Mr. Vice Chancellor, sir, I was particularly interested and determined to learn about this technology for the main purpose of returning to Nigeria and begin from somewhere in applying it in biomaterials research. However, the chemistry input was nowhere, as there were no synthetic chemistry ready for the challenge. The other area of interest in applying this technology was in defense R&D, in particular, personnel protection. When I became the director and CEO of EMDI in 2005, that's in Akure, a filament winding machine was acquired as customized for us by a manufacturer in Wisconsin, USA. That's on plate 4. That is a machine. Then, shortly after the commissioning, the American engineer that was doing the job, and one of our technical staff shown that. That was in 2009. It was commissioned by a visiting engineer. The reason was that being a strategic equipment, it should not find its way to a third country. This opened the way for the fabrication of prototypes of laminates for ballistic protection and to be able to demonstrate to the military research establishment that we have the capability for collaboration, especially with the Defense Industry Corporation of Nigeria, Kaduna. However, this effort was abruptly truncated in 2010. The result of the rest is the story for another time. Mr. Vice Chancellor, sir, the first opportunity I had after the 6-month research visit to Israel was a 3-year postdoctoral opportunity as a senior research assistant at my former Faculty of Engineering, now Faculty of Engineering and Science, Department of Chemical Engineering, Swansea University in the UK. The 3-year opportunity turned out to be a comprehensive work, largely applicable in civil and structural engineering infrastructure. My postdoctoral investigation involved rheology, which basically is defined as the science of the deformation and flow of matter. Rheologists study the behavior of materials which, because of their nature, are subject to large deformation. They do not obey the Hooke's law of elasticity or Newton's law of viscosity. Understanding of wave, in particular, water wave, was very important to the project. A wave can be described as a disturbance that travels from a medium from one location to another. For the purpose of this research, a wave was seen from the point of view of an energy transport phenomenon, distinguishing them from other types of phenomena. A water wave is thus an up and down disturbance of the surface of the water surface, characterized by a sine wave pattern forming crests and trough. Many of us must have visited the Bar Beach in Lagos at one time or the other and witnessed the formation of tidal wave. Wave was generated at one end with a paddle type wave generator and an absorber or damper at the other end in a laboratory wave flume, which is shown, the model is shown there. On the left side is where the wave is formed, and the other side is where it is damped. My model contribution in this area on the development of is the development of a technique for characterizing cohesive sediments by combining sedimentation and rheological measurements. This has the capability of carrying out measurement of dynamic mechanical properties of non-rigid mud bed under water wave pressure using virtual gap rheometry. The VGR was fabricated and buried in a wave flume where a sediment mud was deposited as a mud. You can see that is the flume, the complex 100-meter facility at the Oxford University. Mr. Vice Chancellor, sir, upon my return to the university in 1994, after realizing that there was not much that could be done here in continuation of any of my earlier research works, I then said to myself that since everything around us is materials, and materials is everything, I decided to take up the challenge of creating new materials from our environment. One of the most obvious environmental menaces during harvest seasons was cocoa pod in the cocoa producing areas of Nigeria, and many harvested banana and plantain trunks scattered everywhere. I believe that a cocoa pod, commonly used in the production of the traditional black soap, could also be used as a filler in different polymeric matrices. The first obvious task for me was to begin an investigation on the basic understanding of the cocoa pod husk and the best ways to extract natural fiber from banana, bamboo, and sisal for use as fillers in polymeric matrices. This was the capability of expanding the revenue base. It has the capability of expanding the revenue base of farmers so that routine fiber extraction by them can be feeding the manufacturing sector, thereby creating wealth from environmental wastes. A comprehensive rheological investigation of the flow behavior of cocoa pod husk powder fluid was carried out at Chemical Engineering Department of Swansea University on private arrangement. It showed that cocoa pod husk fluid is a complex, non-Newtonian, thixotropic, viscoelastic, flocculating system, weakly macrogel-like with weak cross-linked network, where gel-like micro and macro domains are dispersed in a naturally occurring matrix mix. the fluid flow conforms with three major models as established through rheological study. A major part of my research activities in recent years targeted at the development of materials for housing, construction, building, and even automobile infrastructure was natural fiber and particulate extractions from adult banana trunks, tender bamboo, sisal, and cocoa pod husk. These were routinely extracted and size graded, causing me to plant sisal and banana within my compound here in Ife, where students easily obtained specimens for their research. Polyester and epoxy, both thermoset, were used as the matrix materials in the fabrication of the respective composite materials, with those fibers in short forms as the reinforcing components. One of the best works carried out under my supervision by some students involved fabrication of comprehensive hybrid fiber filled epoxy composites with banana, sisal, and bamboo. Sisal cocoa pod husk powder polyester composite and particulate cocoa pod particulate epoxy composite. It was established that sisal fiber had an increased strengthening and stiffening effect within the banana, sisal banana, and sisal bamboo hybrid composites. All products had improved flexural properties with applications in non-load-bearing engineering. All of these efforts were continued at the EMDI. In June 2006, the Nigerian Nanotechnology Initiative became a reality in Nigeria as nanotechnology received full government backing as another priority area following biotechnology, ICT, and space. This was at a workshop inspired by Professors Wole Soboyejo and late Segun Adewoye, funded by the Nigerian government through NASENI, in collaboration with U.S. Africa Materials Institute, USAMI, of Princeton University, New Jersey, USA. The EMDI played a leading role under my leadership. The workshop was held in Abuja, in which stakeholders across the country and from the diasporas were brought together to discuss this technology and the benefits in stock for Nigeria and Africa. The then President of Nigeria, President Olusegun Obasanjo, was keenly interested in the prospects of the new technology. This made the RMRDC set up an advanced materials unit. I was even the chairman of a committee that drafted the first blueprint for the new and advanced materials at RMRDC in 2010. At the end of this workshop, the following beneficial areas were identified for rapid R&D programs. 1, nanomedicine and biological development, including the areas where the institutions that are doing some work related to that area. Number 2, nanotechnology for energy, which is nanoelectronics, in which I happen to be the group leader. Number 3, nano-engineered materials for improved agriculture. For example, milk and crop and animal yield can be protected. FUNAB and ABU are useful in this area. Nanoporous materials for water filtration, so purification, which uses nanoparticles in water purification. We can get more detail of this in the booklet that we already have with us. USAMI and PAMI. Mr. Vice Chancellor, sir, let me remind us of the visit of the US President Bill Clinton to Nigeria in August 2000 as part of his visit to some African countries. One of the fallouts was the establishment of the US Africa Materials Institute, USAMI, by the Division of Materials Research of the US National Science Foundation, based on a proposal prepared by Professor Wole Soboyejo as the principal investigator. This resulted in the establishment of U.S. African Materials Institute at Princeton University, New Jersey. Researchers from Africa were given the opportunity of spending time with their colleagues in the U.S. as fellows at the Princeton University and other participating institutions. My adventure into the world of energy materials, especially nanoscale science and technology, specifically nanoelectronics, is through a collaboration that had worked. I was opportune to be among the beneficiaries of a capacity building program in polymer electronics in 2004 as a USAMI fellow at the Princeton University, together with Professor Williams Shinyombola, our colleagues here at the Center for Energy Research. Others that benefited in this collaboration included Dr. Mrs. Oyatogun of Metamat in the area of biomaterials, late Professor Ayo Osinkolu, late Professor Ben Imasoge, Professor Bamiji Adeoye, Professor A.Y. Fasase, Professor M.A. Eleruja, and many others. The vast majority of beneficiaries were from the OAU. Late Professor Adewoye was the first beneficiary of this collaboration. That was in 2002 to 2003. Polymer electronics. Polymer electronics is an emerging field which focuses on the development of electronic devices that incorporate electrically conductive and semiconductive organic polymers. These semiconducting polymers are made of long chains of repeating units that are chemically doped instead of elemental doping in conventional electronics for making non-conducting polymers to become semiconducting. The most commonly used conductive polymers include polythiophane, polyaniline, polypyrrole, P.PSS, and their derivatives. However, the best used semiconductor in today's conventional electronics is silicon. Collaboration with different experts, particularly synthetic and other chemists, is part of the advancement of this technology. This is why I have personally and quietly been mobilizing chemists through our annual International Materials Congress, NIMACON, which I had been attending annually since the first Congress in 2002, advocating for students and researchers to show interest in this new technology. I had also been presenting talks and papers at different fora as lead speakers to popularize and proliferate the technology, among others. Contributions to emerging organic, electronic, flexible, through bendable electronics. In this adventurous journey in new and emerging advanced materials for energy materials and devices, the focus of the collaborating team was and still is on the development of flexible, stretchable, and bendable polymer solar energy devices, OLEDs, and other storage systems for large, mostly irregular surfaces application, and their electronic and optoelectronic devices as alternative energy resources. As we can see, there are a number of examples of some application areas showing that a device can be bent, and when it is bent, a lot of stress and strains are involved, which means somebody with mechanical property experience must be involved. We can see the third one on the left, which is the fabrication method, which is prospective. By just rolling these devices on like printing newspapers, as we can see. Lots and lots of other interesting applications that I see. Our first major published work was on interface adhesion studies related to organic electronic structures, such as organic solar cells and OLEDs. Ms. Tong, a Chinese American, and Mr. Thompson, an African American, were visiting students at EMDI and as part of their research projects. I helped monitor these projects with others at Princeton. They were given the opportunity of participating in the installation of the new polymer electronics laboratory I was putting together here then at the time. Mr. Vice Chancellor, sir, one of the banes of our rapid development today includes lack of continuity of laudable efforts and also putting square pegs in round holes at all levels of our development. The other significant work in the area of mechanical response of thin films at nanoscale relevant to flexible electronics was the study of large strain deformation of nanoscale gold thin films, which had been electron beam deposited on a thick elastomeric substrate, PDMS. Our study of surface adhesion and the development of write once, read many times, memory devices of the future are significant in this task. Our most relevant collaborative research was the development of pressure-assisted perovskite-based OLED fabrication, which was carried out at WPI in Worcester in 2018 as a Pan-African Materials Institute PAMI fellow. These works involved metal, polymer, organic, and inorganic interfaces that are relevant to organic electronics. The substrate can be rigid or flexible based and stacked layer structure of the similar materials as contained in plate 8. We can see all those layers. The different colors are different materials that are in contact. And when they are in contact and there is a potential difference, current must flow. And the interface becomes extremely important for the lifetime of that device. Mr. Vice Chancellor, sir, in the race to fabricate effective, efficient, and long-lasting conducting polymer devices that will stand the test of time, our works on how organic electronic devices performance can be enhanced have convincingly showed that surface treatment, switching, and surface roughness of the different organic and inorganic layers in contact all appear to be key factors in increasing interface adhesion with implication for increased device performance. In my research group at OAU, an MSc student I co-supervised with Professor Ayo Oluyemi of Chemistry Department succeeded in fabricating a water purification system. This year, the fourth part of the NNI outcomes, which was described earlier. That is plate 9. That's plate 9. That's our fabrication system, water fabrication system, made out of blended clays obtained on campus here and from Moroda. It used synthesized copper nanoparticles in blended ceramics. That is clay, as I said. We plan to refine this work further, if supported financially, for possible patenting. TETFund to the rescue. Mr. Vice Chancellor, sir, at the most critical stage in my career adventure, I was fortunate to be a beneficiary of TETFund grants, in which I was the principal investigator in 2015. I assembled a team made up of 2 engineering physics alumni, one from Elect, one from chemistry, and another from KWASU, Kwara State University, who was later replaced by another colleague from Federal University Oye after the former relocated to France. Our work showed that copolymer-based nanocomposites can be used effectively as active materials in the fabrication of optoelectronic devices, especially plastic photovoltaic cells applications. It has been shown also that use of copolymers as matrix in nanocomposite synthesis result in much lower band gaps compared to homopolymers-based ones. It was also showed that through the incorporation of doped metal oxides in Pani matrix, the optical band gaps of the nanocomposite can be tuned and its electrical conductivity enhanced. Under controlled conditions, nanocomposites are suitable for use in the fabrication of plastic-based optoelectronic devices, especially as emissive layers or whole transport materials in organic light-emitting diodes and devices, light-absorbing materials in plastic solar cells. Mr. Vice Chancellor, sir, again, based on our research, there is prospect for a patent emanating from this TETFund investigation intervention, as this is the first time a copolymer matrix will be involved in the chemical synthesis of nanocomposites. All these can also be finalized when the materials are used in a fabrication of and testing of real devices. We presently do not have the capacity due to lack of facilities. We can see from figure 4 how the nanocomposite, where we have two matrices, for example, Pani and polypyro, and the third one is the copolymer. We can see the lowest peaks for those bars are the ones for the copolymer, which shows how effective the method is. We lost out in the silicon-based electronic technology development over 60 years ago, despite the efforts of late Professor V.A. Williams of the Physics and Electronic Department, later Electrical and Electronic Engineering Department, in the early 70s. The first semiconductor clean room laboratory was set up by the department at the time, and that lab is a relic of itself. In my opinion, sir, we cannot afford not to join in the current race to be one of the leaders in the polymer electronics technology under development worldwide, which is much easier and less stringent than that of silicon-based electronics, already a matured technology. Though the collaboration we had for the advancement of the work being described in this inaugural lecture today is the benefit of the controversial brain drain that has turned to brain gain. Though an experimentalist, over the years, I've collaborated with two of my colleagues, Professor Rotimi Sadiku of Pretoria in South Africa, and late Professor Ayo Osinkolu, then of SAD, OAU, in materials modeling. The detail of this can be found in the booklet that is made available. Mr. Vice Chancellor, sir, once again, the rare privilege I had as the Director and Chief Executive Officer, CEO of EMDI in 2005 gave me the opportunity of managing the lean capital budget and available funds to the Institute judiciously to provide some basic testing and characterization equipment which were then not readily available in most laboratories in Nigeria. We did all we could in this area and were largely successful. These facilities remain in place till today, thanks to the funded, thanks to the self-funded Master of Business Administration of the University of Wales, which I took in 1991 to 1993, which gave me the opportunity of applying modern techniques of managing science-based organization. Play 10. Play 10 is, if we are the first set to be on that part, and you can see the odd one out. Then at the with this and the Oshomalo and natural can-do spirit in me, myself and another colleague in the department with MBA of OAU had been handling the entrepreneurship for physicists and engineers PG course, which is an international course specially designed for graduates and researchers in the developing, that is South-South countries, since 2021 by the Institute of Physics and the ICTP in Italy. This course has been extremely inspiring to the postgraduate students that had taken it over the years. It is worth mentioning that a reverse engineering product, a microprocessor controlled spin processor, was successfully fabricated at TMDI as an in-house project, fully funded by the federal government of Nigeria between 2007 and 2009. It was exhibited at the University of Lagos Research Fair in 2009, with Naseni winning an award. We can see the plate 11 of the product itself. That's the award, and that is the commercial. D is the commercial spin processing spin coating processing system, and that is the display system that went with the main system, as we can see. We also were able to put the first dedicated polymer electronics laboratory together in Nigeria. That's in plate 12, as we can see. That was never in existence, and we can see here we can really fabricate an OLED, which can be demonstrated. And we were on the road to doing this till 2010. Concluding remarks. My career as an academic, which began at the University of Ife in 1977 as a student, then an academic staff from 1982, has led me to this momentous moment of my life here today. I appreciate God for the great privileges I had in this interesting and challenging adventure. I have been, and I'm still, an incurable optimist, no apology to anyone, with great belief in Nigeria and the future of our great country. The short account I have just given us is a tip of the iceberg, considering the many waters that have passed under the bridge, both professionally and in my personal life. However, I cannot end this inaugural lecture without making few remarks, some of which had emanated from my years of advocacy for materials through our professional platform, the MSN, and the annual Nigerian International Materials Congress, NIMACON, 3 of which had been hosted by this great university, and the 23rd in the series is holding this year, hopefully, at LASU in Lagos. 1, the Nigerian Nanotechnology Initiative should be re-engineered, reinvigorated, and reinvented, with the TETFund at the center stage in recognizing the need for increased massive financial support. Number 2, the way forward for Nigeria is the gradual incorporation of advanced manufacturing technologies, AMT, at all levels of our technological, engineering, education, and training. This is a matter of a long-term strategy for the education sector and development of Nigeria. Number 3, directed and focused scientific research for national development should be seen as a matter of national security. This is an expensive venture that we as a nation must be ready to invest in massively. Dedication. Mr. Vice Chancellor, sir, I dedicate this inaugural lecture to the Most High God, the author and finisher of my faith, in whom I have full confidence, and into whose hand I have been and continued to live all situations that are beyond my understanding, and on the part of whom I have not deviated since my loving parents put me on this path. The tools he had used and still using included my loving late father, my best friend in his lifetime, Abiyamo Tòótọ́, the well-known disciplinarian of Egboro land, late Pa Joshua Babatope Awe Fagbulu, aka Ironu Ikoko, 1925 to 1987, who did not live long enough to reap the fruits of his hard labor on us and humanity he voluntarily served. He was diligently assisted in the mission by ensuring we all had good education by his wife, Mrs. Abigail Olarewaju Fagbulu, ní Ogutubi. Whatever the two of you may be at this time, that your boy, popularly called vendor in those years, the newspaper vendor of Ijebu-Jesha between 1969 and 1973, is making you and the rest of the family and the community proud today. I dedicate this inaugural lecture to you both. May your gentle souls continue to rest in perfect peace. It is very important for me to show a deep depth of gratitude to my undergraduate and MSc supervisor, Professor Olawumi Ajaja, who is watching virtually at the moment, Professor Gad Marom of Hebrew University of Jerusalem, my postdoctoral research host, Professor Rodri Williams of Swansea University, UK, and Professor Wole and Mrs. Morenike Shoboyejo, currently at Sunny Polytechnic in New York today. I also dedicate this inaugural lecture to the materials community throughout Nigeria and the members of the MSN, which I have the grace of being used by God to establish in 1999. The National Executive Council is ably represented, and there is a contingent led by the National President, Professor Alafara of the University of Ilorin. I'm very happy to inform that this inaugural lecture has been largely successful, supported, and sponsored by a good number of my co-workers of the community, Ijebu-Jesha, headed by my childhood friends, His Majesty Oba Engineer Moses Olufemi Ilufemiloye Agusoye Isolori, who is here present representing together with the Elegboro in council. The staff is here, even though it's not here in present. When the staff is there, the KBC is there. Olori, you're welcome. Thank you. The Ijebu-Jesha Union's Conference and the Global President, Engineer Oluwagbemiga Abudeore, and his team are all appreciated. Also, my highly appreciative past students and mentees, all making superlative progress in great Ife style, mostly in North America. My spiritual fathers, the Right Reverend Dr. Isaac Iwabi-Olorun Oluyamo, the Lord Bishop of Ijesha North Anglican Diocese, and his amiable wife, Mama Ijesha North, Dr. Mrs. Margaret Olushola Oluyamo. Both of them planned a coup against me over the weekend by giving me a very surprise award at this year's synod, which was a professorial excellent award, the first and the most significant to the audience. I appreciate all of you. It is well with you in Jesus. St. Matthew's Cathedral, Ijebu-Jesha, where I currently serve as the diocesan board member of the standing committee, chairman of the diocesan youth work board, and the choir warden. The dean of the cathedral and his wife, Venerable and Mrs. Babatunde Teyimoson, are leading numerous archdeacons and priests to this inaugural lecture today. You are welcome, sir. My wonderful brother from my mother's side, and father in the Lord, Pastor Odurioke, and his wife. Professor Shola Akiniade, who is seated watching me critically from that angle, was my best man at my wedding in 1987 at Swansea. Also present here. Thank you very much for coming. My local parish church priest, Reverend Samson Ayedun of the St. Mark's Anglican Church at Jegunle, Ilefe, and the congregation, most of whom are here present. My other childhood friend and fellow compatriots, in particular, my 1977 classmates at Methodist High School, Ilesha, the great 77 collectives, are hereby appreciated for always being there for me at all times. I appreciate my amiable and dynamic Professor Bidini Alade Taliatu, the coordinator of the planning committee of this inaugural lecture, including numerous enthusiastic student volunteers, technicians, technologists, and many more. I'm eternally grateful to you all. More specific appreciations and recognitions can be found in the booklet already made available. Mr. Vice Chancellor, sir, I have remained stable and sane in this career adventure so far, to the glory of God, making me to be able to stand before you today in sound and robust health, despite everything. This is due majorly to the love, tolerance, support, understanding, prayers, and encouragement of my immediate family, many of who are in this hall today, and many others are watching live, virtually, from different parts of the world. This team is led by my tolerant, loving, and understanding wife, Mrs. Mabel Olushola Babatope, who is in the United States, and Mrs. Feyintoluwa Babatope, here present, and my wonderful children, Baba Demilade, Mrs. Opeyemi Akoni, Iyanoluwa, Ayomi Posi, Baba Darasimi, Baba D, who is currently writing an exam in school, Baba Joba, Baba J, and Baba Timileyin, Baba T, both who are present here. My loving and wonderful siblings, Mrs. Baba Fisayomi Ajayi, Mrs. Folashade Dayo Aubami, and to the memory of my younger brother, late engineer Bolade Babafemi Babatope, my daughter cousin, Mrs. Oluwaseun Oyekan, and her mother, my auntie, Mrs. Omolayo Unimole, and children have always been there for me. I owe my in-laws deep depth of gratitude for their understanding and love, especially the family of Professor and Mrs. Akoni, my first son-in-law, Demola Akoni. The grace of God will never depart from you all. Amen. I sincerely appreciate God for this special favor on me. 24 hours to the 2024 Father's Day with a gift of my first grandchild. Hallelujah. I cannot but dedicate this inaugural lecture to the authorities of this great citadel of learning, Obafemi Awolowo University, formerly University of Ife, Ile-Ife, for giving me the rare opportunities to be able to stand before you here, telling you about my career adventure. I especially recognize and appreciate you, sir, my Vice Chancellor, for your understanding and encouragement over the years before you even became the Vice Chancellor. Thank you very much, sir. On my own part, a Yoruba saying goes thus: Apẹ́ kó tó jẹun, kì í jẹ bàjẹ́, to which I subscribe fully. Whenever one is faced with many trials and tribulations of life, sometimes very difficult, just truthfully remain focused on your Creator. Truly, our journey is a journey. Our life is a journey. And we make mistakes. And it's how we learn from those mistakes and rebound from them that sets us on the path that we are meant to be. Mr. Vice Chancellor, sir, I sincerely hope I have convincingly showed that everything is materials, and materials is everything in my chosen infrastructure and energy material careers journey. This is the 384th inaugural lecture as presented today, the 9th of July, 2024, to the glory of God. I say a big thank you for being part of this inaugural lecture.
Congratulations once again. Babaniyi University, Ife. Certificate of Presentation of Inaugural Lecture. This satisfies that Babaniyi Babatope, a professor of material science in the Department of Physics and Engineering Physics, Faculty of Science of Babaniyi University, Ife, Nigeria, delivered the 384th inaugural lecture titled Materials, Everything, and Everything is Materials. My adventure in the world of infrastructure and energy materials. This day, July 9th, 2024. Congratulations.